So this is a comparison problem to that first problem. Let's say the problem looked like this. Now, right away, you might look at that and go, well, that's the same problem. It's not. I have x squared plus 1 just sitting there, not x squared plus 1 quantity squared. Okay. It's still a quotient. I still don't like quotients. Quotients mean I got to do some kind of crazy work in all of calculus. But if I put x squared plus 1 to the negative 1 power, if I still kind of thought of that as a group to the first power, then yeah, I can sort of see how this is very similar to the last question. And so I'm going to write this problem like that. Now, I know something scary is coming because I've seen this scary movie before. You may not. Or if you're thinking about what happened on the last problem, you might be thinking, what the heck is she talking about? Something scary. Okay. Let's keep going. I'm going upstairs. I don't even know that the killer's up there, right? So I'm doing my U sub. La 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 la. Well, that looks good. Oh, put my dx. Everybody's happy. Everything I want is there. I don't even need to put anything. Life is good. Yeah, I'm feeling awesome. And then I open the door. The guy jumps up. What is the scary thing that's going to happen? What is it? It's only scary in math. What am I supposed to do next? How do I find the antiderivative of u to the negative 1? What am I supposed to do next? And if you're hesitating, why are you hesitating? Okay. U to the negative 2. Okay. U to the negative 1. What's the problem? Okay. We can't divide by 0. Can't divide by 0. That's like, one of the things you first learn, like, thou shalt not divide by 0. You can't divide by 0. Divide by 0 is not defined. It's undefined in mathematics. So all our magic backward power rule stuff goes to crap. No, 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 no. We can't write that. That's not, and that's ridiculous. Okay. So what the heck are we supposed to do here? This is its own special thing. It's got its own special rule. It's the reason the rule for this works the way it does is because you probably don't remember this, but the rule for taking the derivative of a natural log of something worked a special way. So this is our special log rule, our special I'm going to call it the natural log rule. When we take the antiderivative of u to the negative 1, that is the natural log of the absolute value of u. Okay. The other way you sometimes see this is you might see it as 1 over u du. Or you might see it written as du over u. this one, or this one, or this one, all different versions of the same problem that essentially falls apart when you try to use backward power rule. U to the negative 1 won't backward power rule. Because when you try to backward power rule it, you end up with a 0 exponent, which that's okay. But then you have to divide by 0, and that's not okay. Now, there is no way that you would look at that and go, oh yeah, that totally makes sense. It doesn't make sense that it's natural log. It's not intuitive. You don't go, okay, I can kind of see it. No. Other than the fact that when you take the derivative of the natural log of something, you get 1 over. And if you remember that, then that makes this a little bit more like, oh, so this is the, if I got this kind of derivative, 1 over something, it came from the natural log of that thing. That's the only way you kind of make sense of it. Other than that, you just kind of memorize it. Okay. Use in the denominator quotients, lots of the time are going to work great, except when they don't. That's what Mr. Bumgarner loved to say that. He's like, that works all the time except when it doesn't. Backward power rule works all the time except when it doesn't. Backward power rule works great on U to any power except negative 1. And it actually, if you look up the rule, that rule for the that antiderivative rule, it is actually specified that the process won't work if the exponent is a negative 1. So, how is that going to affect you? Well, when we run into this kind of problem, which ends up doing like this, and I go through the U sub, and you're getting ready to take the antiderivative of U to the negative 1, you've got to remember, oh, I've got a special rule. This is the natural log of the absolute value of U plus C. The absolute value has to be there because you can't take the natural logs of negatives. So you got to always make sure that you're going to take the natural log of stays positive or the whole function won't work. In this case, it actually, x squared plus 1 would always be positive, so we wouldn't necessarily need the absolute value there, but it's still good to write it. Oh, I'm forgetting my 1. Wait, will I hit the little stick now? Nope, I didn't. I still hit the eraser. Natural x squared 1 plus C. So that would be the answer. When we mix a lot of antiderivative problems together, and that might ultimately happen if you're in a next level or a college level math course, calculus course. If you're doing a lot of different antiderivative problems together, sometimes it's hard to find the U sub problems, and sometimes it's hard to remember to do the natural log. Sometimes what students do is you start to think, oh, anytime I see a fraction like this, it's going to be a natural log, and that's not true. This was a big quotient, and it wasn't a natural log problem. A lot of times in AP, that's the mistake I start seeing students make, is anytime we see a quotient, they're like, it's a natural log. No, they're not all natural logs. They're only a natural log if the U substitution takes them to this. Okay. All right, so let's do one more. You kind of know it's going to be the special natural log, so you can, it's not a big scary thing. I'm actually going to do one more kind of a little weird thing here. So let's do this. Let's do 4 over 2x minus 5 times dx. Let's see if we can find the antiderivative for that.